Now we are on section C of the sample paper. And in this section, we have some 6 questions with 3 marks each. Well, I'll be solving its odd part as well. Now, the first question here is question number 26 from this section. Let's check here what we need to prove. The question says that there is a triangle ABC where D is the midpoint of BC, E is the midpoint of AC, and F is the midpoint of AB. And in the first part, what we need to prove here that the triangle, that is the triangle here is triangle FBD. This triangle, we need to prove it similar to another triangle. And what is that? The triangle, other one is this. That is DEF. So we are going to prove these two triangles similar. We have to prove. Now, for proving this, I'm going to apply the midpoint theorem. So first, by applying midpoint theorem, which I've studied in class 9th. Yeah, in class 9th, you have studied. So what we know that line joining the midpoint of two sides is parallel to the third side. That means line joining the E being the midpoint of AC and F being the midpoint of AB. Therefore, this should be parallel to BD. So let me first shed the triangle and quadrilateral, which I'm going to prove it a parallelogram. I'm going to prove this quadrilateral FDEF is a parallelogram. Now, how will we prove that E is the midpoint of AC, F is the midpoint of AB, and line joining the midpoint of two sides is parallel to the third side. So this way, what we can say that here FE is parallel to BC. Since it is parallel to BC, it will be parallel to BD as well. And what else we have? Yeah, we can also say this is parallel to this. That is DE is parallel to BF. And the third is this. So we can say that here FD is parallel to EC. Well, it is parallel to AC, and as you know, parts of parallel lines are parallel. And this is from the midpoint theorem. Now, if using these two, right? Using these two, let's say what we have proved here, that EF is parallel to BD and FB is parallel to EC. So it becomes a parallelogram. So from here, from 1 and 2, you can straight away write that this is BDEF is a parallelogram. And if it is a parallelogram, we can write their opposite angles. Say angle 1 is equal to angle B. And using alternate interior angles, say angle 3 is equal to angle 4. So check, we actually proved the triangle similar. And how is that? Angle 1 is equal to angle. We may mention the name of the triangle first from here. That is in triangle FBD. And the other triangle here is triangle DEF. We have proved angle 1 is equal to angle B. And we proved angle 3 is equal to angle 4. So one by opposite angles of parallelogram and the other by alternate interior angles. So therefore, these two triangles become similar. That is the triangle here, which is FBD is similar to triangle DEF. And that is by AA similarity. So once that's what we need to prove in the first part. And I can see we have one more part here, is to prove this triangle. What is that triangle here? Yeah, this triangle, that is DEF, is similar to ABC. Now we have already proved one of their angles has equal, as I can see here, that we have proved this angle 1 is equal to angle B. Now, since as we proved these two sides parallel, so same way we can say that this is also a parallelogram. So I can see that if I take this one, from this, that is FB. Is it EF? No. From these two. From these two, we can say that this time it is EFDC is a parallelogram. Now, if it is a parallelogram, same way I can say that angle 3 is equal to, angle 3 will be equal to what? This angle 3 will be equal to angle C here. Right, so let's prove the triangle similar. We have the triangle DEF and triangle ABC. So in this triangle, what you can see that we have angle 1 is equal to angle B and angle 3 is equal to angle C. So therefore, we can say that the triangle DEF is similar to triangle ABC. And similarity condition is again AA. So that's what we need to prove in this question. Let's move to the next section. Now we are on the OR part of this question number 26. And it says that ABC is a triangle where P and Q are, these are any points, right? They are points on side AB and AQ, AC respectively, such that PQ is parallel to BC. That means this line PQ is given parallel to BC. We are given these two lines as parallel. So just keep in mind. And we have to prove that the median AD drawn from A on BC. That means it's very important to understand that here AD is the median, right? And this median is for AD is the median of the triangle ABC. So we know median is what? A line joining the midpoint of a side with its opposite vertex. That means we are given, I can write this. I should write it first, that we have BD is equal to DC. That will help you while in the proof. So this is given. You should keep in mind that this is given. Or you may write given in the beginning as well. Now what we need to prove here, that PR is equal to RQ. That is PR is equal to QR. That's what we need to prove. So let's use the property of the parallel. From parallel, what you can see here that we can write this angle is equal to, since these two lines are parallel, so we can say that since these two lines are parallel, what do you know? That their corresponding angles should be equal. So we can say here that the corresponding angle, say I took this one, this should be equal to this angle. And likewise, you can also say from the same property that using corresponding angle, even these two angles will be equal. Using corresponding angles, even these angles should also be equal, right? So I can say that this angle is equal to this. All right, so let's start proving the triangle similar. What you can figure out that if I prove this, take this triangle and this whole triangle, right? I can prove these two triangles similar as we have already proved two angles equal. So that means we can say triangle APR is similar to triangle ABD, and that is by AA, as two of its corresponding angles are equal. So therefore, we can write this sides proportional. I take AP over AB because as you can see, AP corresponds to AB. So AP over AB is equal to, I'll prioritize PR as we have to prove PR equal to BD. So that is PR corresponds to BD, PR over BD. And that is from the property that corresponding sides of similar triangle. We have one more triangles. I can prove this triangle similar to this whole triangle. That is triangle AQR is similar to triangle ACD. And property will be same, that is from A similarity. So here, therefore, I can again write their corresponding sides. Let's say AQ AQ being the first two letter, corresponds to AC. And here I'll be writing QR. This is QR correspond to CD. And same if I mark it equation 2. Now, we can also say that here these two angles are equal and these angles are equal. So same way I can write the triangle AP. I can write triangle APQ similar to triangle it's ABC. And same way I can write their corresponding sides, that is AP over AB is equal to AQ, that is first and last, AQ over AC. And the reasons remain same. I'll be marking that is this is A, corresponding sides of similar triangle. So what you can observe here that I actually proved from the first equation, if you observe, I proved their LHS. I proved their LHS as equal. So I can write their RHS also as equal. I can write their RHS as equal. That means from equation from this is from 1, 2, and 3. I can say that these two are equal. That is PR over BD should be equal to QR over CD. And check, we were given BD is equal to DC. So I can cancel them and that results to give PR is equal to QR. And I think, yeah, this is what we had to prove, that is PR is equal to QR, and we proved it. Now we are on question number 27. It says the sum of two numbers is 18 and the sum of their reciprocal is 9 over 10. That's from the chapter quadratic equation. And we have to find the numbers here. So what we can do here, let's say, if I take the numbers, say, let the two numbers, right? So this is two numbers B. I'm taking one as X. So the other has to be what? The sum is 18, so the other has to be 18 minus X. It's not X minus 18, right? It's a very common problems that we have the total as 18, right? The total as 18. So if one is X, the other will be 18 minus X and not X minus 18. Further, we are given the sum of their reciprocal. That means the sum of their reciprocal is what? 1 is X. The reciprocal of X is what? 1 over X. So 1 over X plus the reciprocal of the other, which is 1 over 18 minus X, should give you 9 over 40. Yeah. Now, if I take LCM here, it's going to be the product of these two, which is X multiplied by 18 minus X. So this is 1 multiplied by 18 minus X is this, and 1 multiplied by X is this, which is equal to 9 over 40. Now I can simplify this, right? I can cancel this and I can also reduce this 9 one time and 9 two times. So what do we get after further simplification? Let's say I do it here. So we are left with 2 over here in the numerator. And if I open this brackets, it's going to be 18x minus x squared. And that is equal to 1 over 40. In the next step, I'm doing cross multiplication. So this is 80 and this 1 multiplied by this is 18x squared minus 18x minus x squared. Now writing in the standard form, on the left hand side, it will become positive. This will become minus 18x and this is positive 80. I just transposed these two to the left hand side. So it will become 0. Now from the factors of 18, we need to get how much? 18. So it's very easy, right? 18 into 10. Oh, yeah, 18 into 10. How come? It should be 8 into 10. 8 into 10 is 80 and their sum is 18. Okay, so I'm going to do middle term factorization where I'm splitting minus 18 as minus 10x minus 8x plus 80 equals 0. If I take x common from the first two term, I'm getting x minus 10. And if I take minus 8 common, as you know, if I take minus common from here, the sign will get reversed. So it's dividing this by minus 8 is minus 10 equals 0. Now I can write this as taking x minus 10 common from the whole, we are getting this. Now we have to get the values of this now. So we need to equating the first one with 0. I'm getting x as 10 or x minus 8 equals 0. So x is equal to 8. So you can say that the two numbers are 8 and 10. So because if I'm going to plug in x as 10, I'm getting 8 from here. And conversely, if I replace x with 10, I'm going to get 8. So we are not, we just have to write the two numbers. So we'll say that the two required two numbers, therefore the two numbers are 8 and 10. That should be the answer for question number 27. So the next question, that is 28 from the chapter polynomials. He says alpha and beta are the zeros of this polynomial, this one. And then we have to form a quadratic polynomial whose zeros are alpha square plus beta square. So now the first thing that we do in a question like this is, let's say first I write the question here. What you can see that since alpha and beta are zeros of this polynomial, what is the sum of the zeros of a polynomial? We know that sum of the zeros, say the zeros are alpha beta, is minus b by a, that is negative coefficient of b over c. So minus of minus 5 is what? Positive 5 by minus b by a. And if I say the product of the zeros, that is alpha into beta, is c by a. The c is 1 here, a is 6, so that is 1 over 6. Now check here, we have to frame a quadratic polynomial, and the standard formula is what? K bracket x square minus the sum of the zeros, I'm writing sum only, into x plus the product of the zeros, that is alpha, sorry, product, not alpha beta, product of the zeros. Now the polynomials that we have to form here has zeros as not alpha beta but alpha square plus beta square. So the sum will be what? Sum of their zeros will be what? Alpha square plus beta square. Why? Because their zeros are alpha square and beta square. Times x plus the product of the zeros has to be again the product of these two, that is alpha square into beta square. Now here you can see that we have the values of alpha plus beta, and we have an alpha into beta, but we have to frame alpha square plus beta square. So for that, what I'll suggest you just to write in the rough, that is the formula for a plus b whole square. And what you know that it is equal to a square plus b square and plus 2ab. So if I transpose this number to the left hand side, what we are going to get is minus 2 alpha beta. So this we can say that alpha square plus beta square can be replaced with alpha plus beta whole square minus 2 alpha beta. Now you're wondering why I'm doing so. This is because we know the values of sum and product, alpha plus beta and alpha into beta. So continuing with the working, I can say this is k bracket x square minus replacing this whole thing with this here. So that is alpha plus beta whole square minus 2 alpha beta times x plus the product of the zeros. I can write this as alpha beta whole square also. Now for the next part, I'm going to replace these values. I can replace alpha plus beta from here as 5 by 6. So it should be 5 over 6 square, right? Square minus 2 times alpha beta. 2 into alpha beta from here is product of alpha beta. That is alpha into beta is this. Should be enclosed in another bracket, right? Now, so many brackets are there. This is x plus the product of the zeros, that is square of product of the zeros, alpha, beta. Now this is k here. I'm going to simplify it. So what is this? This is 25 over 36. This is 25 over 36 minus, that's 2 over 6 times x plus 1 over 36. Next step for simplification is I'll take LCM. So this is going to be what? The 36 is the LCM here. This is 25 and this should be multiplied with 6. So 25 minus 6, 12. Yeah, that's 12. So it's going to be, on simplifying this, I'll write this as 13x by 36 plus 1 over 36. And we have one more step to do. That is taking LCM as 36 is going to be 36x squared minus 13x plus 1. Is it correct? Yes, should be 13x squared minus 13x plus 1. I can cancel this and we'll declare this to be the quadratic, required quadratic polynomial whose zeros are alpha squared plus beta squared. One more time I should write it. We have to obtain this, which is 36x squared minus 13x plus 1. In question number 29, it says if sine theta plus cos theta is equal to 1, then we have to prove that cos theta minus sine theta. It's cos plus sine is 1, and we have to prove cos minus sine is this. And now, one thing is very clear that we must have to obtain the square of this because we can see there is a plus minus of this. Now, let's say what is common between them. First thing that I'll do is to do the squaring of this both sides. So if you do so, it's going to be what? We are going to get cos square theta plus sine square theta plus what? 2 times sine into cos. 2 sine theta into cos theta. And that is equal to 1. Right? Am I right? 1 square is 1. And this is a square plus b square plus 2ab. What we know that sine square plus cos square is 1. So is cos square plus sine square. So I can replace this 1. So we'll get 1 plus, this is 2 sine theta, 2 sine theta dot cos theta is equal to 1. So I can cancel this. Further, I can say directly that is 2 sine theta dot cos theta is equal to 0. So let's mark this as equation 1. As I said in the beginning that from this, it gives an hint that we first have to find the square of this. So if I start with the LHS of what we have to prove, it is we have to get the find value of cos theta minus sine theta. So instead of finding cos theta minus sine theta, I should find the square of cos minus sine. So if what is cos minus sine whole square? It should be what? A square, that is cos square, plus b square, that is sine square, minus 2ab, minus 2 times cos into sine, or sine into cos is also same, right? So I can write in any order. So we'll keep this cos theta minus sine theta on the left hand side as it is, square. So once again, I can replace this cos square plus sine square. As you know, sine square plus cos square is 1. So is cos square plus sine square. This is 1. And minus, this is 2 sine theta dot cos theta. Now what you can figure out from here that the value of this is what? 0. So I can replace this with 0. So what is 1 minus 0 is 1, right? That is 1. And if this is cos theta minus sine theta. If I transpose this square to the other side, it will be under root 1, and under root 1 is what? Plus minus 1. So we'll say this is hence proved, right? Now in question number 30 from the chapter areas related to circle, it says that a minute hand of a wall clock is 18 centimeter long. Find the area of the face of the clock described by the minute hand in 30 minutes. So let's say if I make a clock here, which is not necessary for the student to make in the exam. I'm doing so to understand this. So this is what the minute hand, and what do we know that this minute hand, I can take this to be the area swept by this will be what? Will be equal to the radius of the, sorry, will be equal to this the length of this, right? The length of this minute hand can be taken as the radius. Now, it is how much time it has? Yeah, minute hand of the clock, and this is 18 centimeter. So area described by it in 35 minutes, somewhere 15 minutes, it's 30 minutes over here, and this would be 60 minutes. So what we have to find is the area swept by this in 30 minutes. So that means we have to find the area of this sector, that is a major sector. This is what we have to get the area of this sector. Now we know that for finding the area of this sector, what we know, the formula for finding the area of the sector is, this is what? Theta over 360 into pi r square, right? Theta over 360 multiplied by pi r square. So clearly r we know, as we discussed earlier, that here the radius is this only. So we can say the length of the arc is its radius. So I can say this is 18 centimeter. We know this is 18 centimeter. So what we don't know is the angle, that is the theta here. Now for that we can use, we can figure out here. Let's talk about, right, say this is, I'm taking the time in minutes. This is time in minutes, and this is the angle, that is the theta. So we know that in in 60 minutes, right, as you must be knowing that in 60 minutes, the minute hand does one complete revolution, right? So when say that in 60 minute, it makes 360-degree. So in 1 minute, it should be what? 360 divided by 60, that is 6 degree. And we have to get for how many minutes? We have to get it for 35 minutes. So it should be what? 35 into 6. Am I right? Yeah, it should be 35 into 6 only. That is 210-degree. So we can now find the area of this sector, and the area of the sector, as we using this formula theta, we calculate it as 210 over 360 multiplied by pi, replacing pi with 22 over 7, and r square, r is 18. Yeah, that's 18 into 18. Now if I reduce, I can reduce this, say 7 1 times, 7 3 times. The zeros get cancelled, and 3 1 times. This is 3 1 time, and 3 12 times. Yeah, this also can be cancelled. I'm reducing it further. That is 6 2 times, and 6 3 times. And this can be cancelled. I'll reduce it. So that comes out to be 11 into 18 into 3 is what? 72. Right. 18 into 3, that's 54, not 72. So this is 4. 5 plus 4 is 9, and 5. So it should be 594 centimeter square. So this should be the answer for the question number 30th.